Hey guys, Miss Irons here. I just want to go through a couple things for today's lesson on the 25th, and then you're going to use this stuff for your project tomorrow, so the Pizza Hut project. So I'm going to make another video explaining what to do for the Pizza Hut project. All your instructions are linked in the Google Doc. So I'm going to turn my camera off. I just wanted to say hello and talk you through some of these notes. So from your Google Doc, you should watch this video talking about probability of compound events. That's going to go through some of these notes that I'm about to walk you through, and it has some good examples, so I recommend that you watch this video. After you watch the video, go to the Independent Notes tab, and it's going to open up this page on Math is Fun. So, probability of independent events. So we talked about what probability is. When you're talking about probability, you can have dependent events or independent events. Dependent events are where what happens depends on what happened before, such as if you're pulling cards out of a deck of cards, if you're not putting whatever card you pull back into the deck, you're changing how many cards you're pulling from each time. So you start with 52 cards, but if I pull a card, now you only have 51, and so on. An independent event, which is what I'm going to talk about right now, is not affected by previous events. And this is the important idea about independent events. A coin does not know if it came up heads before or not. So independent events do not depend on what came before. So that's why it's independent, because it doesn't depend on anything. When you flip a coin, you have a 50% chance at heads and a 50% chance at tails. And that's every time you flip that coin. It doesn't matter what came before. So that's this idea about an independent event. If you're not changing what's happening, like every time you roll a dice, if you're not changing those numbers on that dice, then that's an independent event each roll. And so you can read some more about that here. When we're talking about the probability of an independent event, probability, again, is how likely something is to happen. So we talked about this a little bit yesterday in the probability notes. So I'm going to skip through this. There's more examples here. Rolling a dice, flipping a coin, things that we talked about yesterday. So if you're having problems with understanding probability, I suggest you go watch the probability video from yesterday on simple probability. When we're talking about ways to show probability, again, that's from 0 to 1. So if something has a 50% chance, that's the even chance. It's equally as likely to happen or not happen, like flipping a coin and getting heads. So you can read through that. What we want to talk about today is what happens when there's 2 or more events. Excuse me. So we can calculate the chances of 2 or more independent events by multiplying the chances together. So for each toss of a coin, a head has the probability of 1/2. So if you toss the coin once, you have a 1/2 probability of getting a head. If you're tossing a coin twice, you have a 25% chance of getting heads twice. Okay, so we're looking at the probability of getting heads 3 times in a row. So you take the 1/2 times the 1/2, and you get 1/4. If we're looking at 3 heads in a row, it's 1/2 times 1/2 times 1/2. You multiply all the probabilities together. So 1/2 times 1/2 times 1/2 is 1/8. Okay, so why is it unlikely to get, say, 7 heads in a row when each toss of a coin has a 1/2 chance of being heads? So your probability is less than 1% of getting 7 heads in a row. And why that is because you have to multiply all the probabilities together. So each time has that 1/2 probability. So you have to multiply those all together. So given that we have just gotten 6 heads in a row, what's the probability that the next toss is also a head? That is still the probability of 1/2. So what came before doesn't affect what's about to come when we're talking about independent events. We're talking about notation. So P is probability of. So we've been talking about probability as P. So for independent events, what's the probability of A and B? So what's the probability of A and B? Because it's and, we're going to multiply them together. So you take the probability of an event A occurring and the probability of event B occurring and multiply them together. So let's go through this example. So when we're looking at this example, it says your boss, to be fair, randomly assigns everyone an extra 2 hours of work on the weekend evenings between 4 and midnight. What are the chances that you get Saturday between 4 and 6? So there's two different things that we have the probability of. The probability between Saturday and Sunday and the probability of what time. So our probability of the day, there's 2 days on the weekend, Saturday and Sunday. So we wanted the probability of choosing Saturday, which is going to be 1/2 because Saturday is one out of the two options. When we look at the 2 hours that we want from 4 to 6 out of the 8 hours of 4 to midnight. So 4 to midnight, 5 o'clock would be 1 hour, then 6, 7, 8, 9, 10, 11, and then midnight. That is a total of 8 hours. So 4 to 6 is 2 out of the 8. So that's a probability of 1/4. So the probability of choosing Saturday, of getting Saturday from 4 to 6 is the probability of Saturday, which is 1/2, times the probability of getting the hours 4 to 6, which is 1/4. But when you multiply those together, you get 1/8 or 0.125, which if we change this to a decimal or to a percentage, we move the decimal 2 places to the right, we get 12.5% chance. Okay. So there are more examples here for you to read through. Your assignment then, what we want you to work on to practice independent events. If we get to the bottom here, there are 10 questions here at the bottom for you to fill out. So those are for your practice problems. Your assignment is on Edulastic. So I'm going to go ahead and go back and talk about, that is Algebra 2, talk about dependent events. So let's open up and talk about dependent events when we're talking about conditional probability. So how to handle dependent events in conditional probability. So we just talked about independent events, so let's look at dependent events. So when events are dependent, they can be affected by previous events. For example, when you're choosing marbles out of a bag. So if you have 2 blue and 3 red marbles in a bag, what are the chances of getting a blue marble? Well, that's just simple probability. 2 out of the 5. So 2 in 5 chance, or 2/5. But you chose a marble, so next time our chances change. So if we pick a marble, now if we got a red marble, our chance of getting a blue marble is now 2 out of 4. If the marble that we chose originally was blue, now we have a 1 out of 4 chance. So the probability changes based on what happens before. This is because we're removing the marbles from the bag. Okay, so the next event does depend on what came before. If we replace the marbles in the bag each time, then our events are independent. So I mentioned that a little bit earlier about independent versus dependent. If there's replacement, so let's say you pick a marble and then put the marble back in, and your chances don't change, that's an independent event each time. So when we're talking about dependent events, we can make what's called a tree diagram. Okay, so it's a picture that shows us what's going on. So let's say originally, again, we have our bag of marbles. You have a 2/5 chance of pulling a blue marble, 3/5 chance of pulling a red marble. So we're going to write that probability right on the side of our tree diagram. Okay, and if this link will tell you more about tree diagrams, I'm just going to walk you through this one. So now if we first choose a blue marble, then my probability of choosing a blue marble from the bag the second time is 1/4. And the red marble is 3/4. And it shows you what happens each time. If we first chose a red marble, then our probability of choosing a blue marble is 2/4. And the probability of choosing a red marble is 2/4, since there's 2 blue and 2 red. And then we can do the same when we get to pulling the third marble out of the bag. So if the blue marble was selected first, there is now a 1/4 chance of getting the blue marble and a 3/4 chance of getting a red marble. So that's what we talked about up here on the bottom, or on the top. So what are the chances of drawing 2 blue marbles? Well, if we follow that line of the tree, I would choose a blue marble, then I choose a blue marble. Again, we're still multiplying our probabilities together. So 2/5 times 1/4 is 2/10 or 2/20, which is equal to 1/10. Okay, so we multiply our chances together. Same as we did before with independent events, except now my probabilities are changing. And that's the important part here. When we talk about notation for dependent events, okay, so probability of A, okay, probability of A. We get our marbles, an example from before. Event A would be getting a blue marble first. That probability is 2/5. Event B is getting a blue marble second, which, if we look up here at the tree diagram, was 1/4. So we have to say which one we want. We're going to use this symbol, which is a straight line, to be given. So what's the probability of B given A happened? What's the probability of B happening given A happened? So what's the probability of picking a blue marble given we've already picked a blue marble? So what's the probability? This is called conditional probability. It's based on the condition of what happened before. What is given to us? Okay, so the probability of getting 2 blue marbles is the probability of getting a blue marble, then the probability of getting a blue marble. So when we're talking about probability of event A and B, we're talking about the probability of A times the probability that B happens given A happened. We have to follow through the tree diagram. So you guys can feel free to read through these other examples here. So drawing 2 kings from a deck is going to work the same way. When we're talking about compound probability, we can also find probability like this example here. So 70% of your friends like chocolate, 35% like chocolate and strawberry ice cream. So we want to know what percent of those who like chocolate also like strawberry. So how many people in the 70% are also in this 35%? So we want to know the probability that someone likes strawberry given that they like chocolate. So we're going to take the probability of chocolate and strawberry. So that was our 70 or 35%, excuse me. So there's 35% of our friends like chocolate and strawberry. So we're going to take that 35% and divide it by the probability that people like chocolate, that your friends like chocolate, which was 70%. So we're going to take the 35% and divide it by the 70%, which is 50%. So 50% of your friends who like chocolate also like strawberry. Okay, that's a little bit harder to understand. So feel free to read through the soccer game example. It walks you through creating a tree diagram, which is going to be important for you to know. When you're done, okay, there's a couple more examples here. When you're done, down at the bottom again are 10 questions based off of this compound probability. So you're going to watch the video, hopefully watch this video, read through these notes and do those problems at the bottom. Once you're done with reading these notes and watching this video, you're going to do the compound probability assignment on Edulastic. So have fun, and I'll talk to you guys later. Bye.